Welcome back to Math Hour. I'm your host, Thomas James, and today I'm here with Pythagoras.
Hey there, kids!
Pythagoras was an Ionian philosopher and mathematician born around 570 BC in Samos, Greece. He was born to his mother, Pythias, and his father, Minosarchus, who was a merchant from Tyre, modern-day Lebanon. Pythagoras spent his early childhood in Samos, and as he grew up, he began accompanying his father on trading trips around the world.
So, Pythagoras, have you always been a hard-working student, always high-achieving?
My father once took me to Tyre, where I studied under scholars from Syria. Afterwards, I studied extensively under a variety of teachers. I learned poetry and how to play the lyre. Apart from scholars in Syria, I studied under wise men of Chaldea. I also studied philosophy under the Greek thinker Pherecydes of Syros. At the age of 18, I traveled to meet a master of mathematics and astronomy named Thales in Miletus, Greece. This meeting sparked my interest in science, mathematics, and astronomy. I also studied under Thales' student Anaximander. After spending 10 years in Egypt, where I studied and was later captured, I returned home to my mother and father in Samos in 520 BC. I opened a school called the Semicircle. My method of teaching was different and appealed to few. At the same time, leaders of Samos wanted me to get involved with the city administration, which didn't really appeal to me. Later on, I set up a brotherhood consisting of both men and women called the Pythagoreans, which developed into a religious philosophical school with considerable political influence. The Pythagoreans were divided into two sects. One whose learner lived outside of the school, called acoustomatics, and the others who lived in the school without personal possessions and had to follow a strict vegetarian diet called the mathematikoi.
Pythagoras' contribution to mathematics was very important. He is best remembered today for his concept of numbers. He believed that everything could be reduced to numbers, and these numbers had their own characteristics, strengths, and weaknesses. According to research, Pythagoras married his first pupil at Croton, Theano. She was also a philosopher in her own right. They had a son named Pelagius and three daughters named Damo, Arignate, and Maya. Pythagoras was very outspoken and created a lot of enemies. One of his enemies encouraged a mob against the Pythagoreans and set fire to the building where they were staying. Pythagoras was able to escape. A theory of Pythagoras' death is that after the fire, he then went to Italy and starved himself to death. Another theory is that he was caught in a conflict between the Agrigentum and the Syracusans, inhabitants of a city in Italy, and was then killed by the Syracusans. Whatever the cause of his death was, we know that he died around 500 BC in Metapontum, Italy.
Thomas James back here with Pythagoras, and we're just learning a little bit more about the Pythagorean theorem. So correct me if I'm wrong, Pythagoras, but the square of the hypotenuse, which is the longest side and opposite of the right angle, so this area of this square is the sum of the area of the other two sides squared.
Correct. So the formula would be a squared, so this area right here of this square, plus b squared, which is this one right here, is the sum, which equals c squared. So this big square right here.
Thank you, Pythagoras.
No problem.
We're going to start with a right triangle that has side lengths A, B, and C. We're then going to take a congruent right triangle and rotate it 90 degrees counterclockwise. Now, if we were to connect the two inner points, we would make a parallelogram. Since we rotated our triangle 90 degrees, we can add that in. We can mark that off. And so now if we want to find the height of this parallelogram and the width of this parallelogram, we can simply take it aside and we can mark up the side lengths. So we know that this would be attached to A on the bottom, and it would also be attached to C on the side. But if we take a closer look, we can see that the outside of the triangle to the left is side length A. So that shows us that the height of this parallelogram is equal to A, and the width of this parallelogram is also equal to A, which shows us that this parallelogram equals A squared. We're now going to do something very similar, and we're going to take another congruent right triangle, and this time we're going to rotate it 90 degrees clockwise. We're going to do what we did last time and connect their inner points to make the shape of a parallelogram. Again, just like last time, we rotated this triangle 90 degrees. We rotated it 90 degrees clockwise this time, but we can still mark that up. Using the same logic as we did before, we can remove this parallelogram from the shape so that we can find the area. With this shape, we're going to rotate it so that the bottom is flat on our page, and we are just, again, going to mark up what sides would be matching up as if it were back in the shape. So we know that the width is already B, but to determine the height, we're going to use the same logic as we did last time, and we can see that where it would match up would be B, therefore giving us a parallelogram of B squared. Now these triangles on the side were really just to help us get the parallelogram, both parallelograms that we were looking for in the middle. So we're going to take the middle. We will replace it with one solid shape just to keep our lines clean. And this line that we've drawn up top here, that will show that that equals line C, as well as the side here, the bottom here as well, and this side. That shows us that that square right there is equal to C squared. So now we can remember and mark in the fact that the orange parallelogram equals B squared, the yellow parallelogram equals A squared, and that square that we created equals C squared. We are able to use the fact that these two triangles are congruent to help us find our answer. So we're going to simply move that triangle down to the bottom, which will then give us just this square because the top triangle will be gone and the blue triangle will be covered. So remembering that the orange parallelogram equaled B squared and the yellow parallelogram equaled A squared, we can now see in this square that A squared plus B squared equals C squared. For this proof, we have two squares. One square is side A plus B, and the other square has side C. The area of the big square can be calculated two ways. It can be A plus B squared, or it can be the area of the small square plus the total area of the four congruent right triangles in the corners of the big square. As you can see, for the side length of the larger square, we have side A plus B. For the smaller square, we have side C. Our formula shows that the area of the large square equals the area of the smaller square plus the four congruent right triangles. We're going to start this proof with 4 copies of the same triangle. 3 of these triangles have been rotated. One has been rotated 90 degrees, another one 180 degrees, and the third one 270 degrees. Each has an area of A times B divided by 2. We're now going to put them together without additional rotations so that they form a square with side C. To help us solve for C squared, we're going to start by finding the area of the small square. Up above, we can see that the side lengths of the small square are equal to A minus B, as they're not full length. And so that would only mean that the area of the small square is equal to A minus B squared. The area of the 4 congruent right triangles is equal to 4 times A times B over 2, which then will simplify to 2AB. Here we are taking what we already know and rewriting it to find the total area. So we know that our total area is C squared. C squared equals A minus B squared plus 2AB. We're expanding this A minus B squared, and again we're including the 2AB. A times A equals A squared. A times negative B gives us minus AB. We have that twice. And negative B times negative B gives us positive B squared. Again, plus 2AB. I'm going to rewrite this to make this a little bit easier to see and read. That gives us A squared minus 2AB plus B squared plus 2AB. The 2AB's cancel each other out, leaving us with A squared plus B squared. And we'll bring down the C squared just so that we can see it. This leaves us with the Pythagorean theorem of A squared plus B squared equals C squared.
Frankie feels like some fish and chips. He wants to figure out the quickest way to Padres from his bus stop. His first option is to walk 160 meters north, cross the road, and continue another 190 meters west. The total distance is 350 meters. Option 2 is to cut directly across the field, jaywalking across the street instead of using the sidewalk.
Remembering what he learned in 8th grade, Frankie used his Pythagoras theorem to figure out the distances. A squared plus b squared equals c squared. 160 meters squared plus 190 meters squared equals c squared. 25,600 plus 36,100 equals 61,700. So c squared equals 61,700 squared. So c equals 248.39 meters. Option 2, which uses the Pythagorean theorem, is 248.39 meters versus option 1, which is 350 meters. Option 2, shown on our diagram, is traveling across a field, also known as the hypotenuse, would be a faster path to Padros. Leah is at the baseball diamond and wonders what is the fastest way to throw the baseball. Option 1 is to throw the ball from home base to first and then to second base, and option 2 is to throw the ball from home base directly to second base. The second option would be like a diagonal across the baseball diamond. If the baseball diamond has a length of 80 feet, we can use the Pythagorean theorem to help Leah solve her problem. Option 1 is throwing the ball 80 feet to first base and another 80 feet to second base. This means that the baseball would travel a total distance of 160 feet. Or, option 2 would be to throw the ball across from home base to second base. To find the distance, you need to use the Pythagorean theorem, which is a squared plus b squared equals c squared. 80 feet squared plus 80 feet squared equals c squared. 6,400 feet plus 6,400 feet equals 12,800 feet. C squared equals 12,800 feet. So C equals 113.14 feet. Option 2 is 113.14 feet. Therefore, option 2 is the fastest way to get the baseball across the field.
And that brings an end to another episode of your favorite math show. Special thanks to our special guest star, Pythagoras.
No problem.
Your host, Thomas James, and Pythagoras are out.